All right, well, we might start it. We've got over 100 here already. Firstly, good afternoon. Good morning to some, probably, depending on where you are. This is our first webinar that Best Environmental Technologies is hosting. It's been co-hosted with Regen Farming, which is Luke Harrington, who I'll introduce to you in a second. Our first webinar has sort of overwhelmed us a little bit. We've had over 280, close to 300 registrations. I just thought I'd introduce myself. So I am Darren Falconer. I'm the business manager for Best Environmental Technologies. In the background there is Jess. Jess can say hello.
Hello.
They've given us our first webinar. From a housekeeping point of view, we've received some questions already via email. Plan is to have Grant talk. And we will have questions and answers at the end of his chat. So probably for about an hour or so, Grant will talk and we'll have about 30 minutes of questions and answers then. We'll have to cut it off at 2 o'clock. So any questions we don't get to, we'll envisage to send over to the panelists in order for them to answer. I've also been asked, are we going to be able to record it? Not everyone can be here for the whole time. So yes, we will be recording it. We'll post that on our social media pages, on our website, and also on our YouTube channel. And we'll send everybody the links to that webinar so you can revisit it. So on that note, I would like to introduce you to Luke Harrington from Regen Farming. Luke has been involved in regen farming or regenerative ag or biological farming, whatever you like to call it, for more than 10 years now. In fact, he actually started worm farming at the age of 19. So he's actually been involved in farming worms and worm juice for a lot longer than 10 years. So Luke is a wealth of knowledge. He is someone who is able to help you out in the field. He's known as a biological field advisor, or sometimes, as he calls himself, even a soil health coach. So in saying that, Luke, I would like to bring you on board and welcome you on board to co-hosting this event.
No worries. Thanks for that, Darren. Yeah, and thank you to everybody who's turned up for our very first webinar. Anything could happen, so bear with us. And I'd just like to say how excited that we are to be able to bring you this with Best Environmental Technologies, these webinars. We're going to do several over the next 12 months, so keep an eye out for them. The next one's going to be hopefully with Joel Williams in about a month's time, and that's going to be a really cracking topic, so it'll be of interest to everybody. So make sure when you see that, register for it. Once we've got the dates and everything sorted in time, we'll put that up. But anyway, today is about cover cropping. There's been a lot of cover crops put in over the last 12 months or 2 years with varying degrees of success. And that's brought up a lot of questions about best practice and the what, why and how of cover cropping. So we thought for our first webinar, we'd get Grant Sims in to talk about his experience and pass on some of his knowledge. Grant's been using them on his property now for nearly a decade. So he's made all the mistakes that we're all about to make. So we'll try and learn from his experience. And he's also got a business called Down Under Covers, where he supplies cover mixes, and that's where I get my mixes from. So yeah, once again, as Darren said, Grant's going to do a bit of a presentation for us. Hopefully we'll answer most questions throughout that presentation, but at the end we'll answer any that pop up. So just got any questions, put them into the Q&A box. Alrighty, Grant, across to you.
Yep, no worries. All right, well, yeah, just like to thank you guys, Best Environmental Technologies and Luke at Regen Farming for asking me to come on here. Yeah, like Luke said, we've been doing mixes for these guys and putting on some of the products on it, inoculating our seed, which I'll get into as well. So, yeah, no, I think it's great that there's some interest there, and hopefully today we can sort of share with some of the things that we've got working, the successes and things that, you know, we've learned where maybe hasn't worked so well. we'll get to a few questions on that as well. But, you know, just with all the years of us playing around with these things and implementing them, and I suppose my time at Vic No Till and the people we've met, you know, what we aren't able to cover or come up with right now today, I'm very lucky to have access to some of the, you know, world leading experts, scientists and that in this field and space. So we can, always got a good source of information there. But, yeah, so firstly, I'll get into sort of why we use cover crops. So I'll just put up, essentially we've got some sodic clays that we do a lot of cropping mainly, and we were finding in dry years feeding out hay, you know, we'd see a positive response the following year where the cover had been. So it sort of made us real aware of the importance of cover. And then, you know, obviously all the benefits of disease and rotations and things. And some of these clays, I'll just put up an example here. When we were getting into our break crops, to say, in our cropping system we're running, we had limited options that could sort of tick all the boxes for us for soil health, you know, whether it be canola or peas, you know, it would tick some boxes, but then we were leaving our soils bare on these sodic clays. Either they got too wet through the winter or too dry and hard over the summer. And so we're playing around with them, what's some rotations and that we could fit in here. And this sort of one example here really blew me away the first time, opened our eyes to how profitable and how successful when we get things happening in diversity. So on the left here, we had a canola with some beans we sowed in, you know, spent some good money on seed and fertilizer and addressed all the nutrients required. But it come in wet and, you know, we had poor establishment and pretty poor crop. The photo to the right is right through the fence, the very next paddock that was a paddock we were really struggling with in getting it into shape. That one we planted about a 13-way mix, a mixture, and I'll get into that, how we choose these and what we do. That probably cost us $30, $40 a hectare in seed, and we put some liquid calcium underneath it to sort of help buffer that sodic effect. The amount of biomass, like when we obviously come to harvest in the two, was just amazing. And what was really cool to see, like things like beans and even lupins and things that might not grow real well in a clay soil or on their own in these sodic conditions, you know, in these mixes, we're finding them, you know, grow up to your waist. There's a lot going on, and you know, we can then harvest them with an animal and turn it into live weight gains and low input, low cost, and be quite profitable. So I'll sort of share how we get this to work and what's going on. So basically, probably a lot of people are aware and that, but what's happening with the cover crops, if you could imagine what you're seeing above ground, you know, there's a diversity above ground in canopy and structures and things, and the same under the soil. So you've got tap roots, fibrous, shallow roots, lateral roots, all different root systems happening. And what that does is it makes these plants more water efficient, because you're allowed, you know, we now can explore more larger areas of soil, but also nutrient efficient too, because every root system or plant can put out different root exudates that can at different pHs or have different abilities of releasing and solubilizing different minerals and nutrients. So through that process, these plants, you know, we've always been taught as farmers and that growing up, you know, we're used to these monocultures as kind of not a natural system, and that any other plant that's not supposed to be there is a weed. But if you could think of a whole paddock of wheat, that all the same root system, all exploring the same area of soil for the same nutrient at the same time of its growth cycle versus this, it's really a more nutrient and water efficient way of getting it out there. This is sort of done some really important things how this magic happens. And one is through quorum sensing, through like fungal associations of the roots. So if you know, what we've got to do when doing this is create an environment for the fungi and these things to, and a soil structure for these to happen. So if we're doing things like tillage, high rates of fungicides, high rates of synthetic fertilizers, that can upset those natural pathways, the mycorrhizal fungi and things like that allow this to happen. So getting that diversity of root exudates in there You know, one, we can choose these cover crops too for certain needs, you know, whether we've got compacted tight soils, we can get the tap roots in to improve infiltration, which will then can lead to holding, you know, water holding capacity, disease and weed suppression. There's a number of things, and we will sort of tailor make these mixes to people's, you know, needs. So if people ring up and tell us, you know, they've got this sort of weed problem or this sort of soil structure problem, we can then choose plants that can do a job to repairing and fixing that. You know, what we also find that this sharing of minerals and nutrients through the plants then goes on to further into, you know, if we're grazing them with the animals, they're getting a greater diversity of, just like us, of food. So you've got more chance of getting your zinc and your copper and all those little minerals. So we're finding now with the animals, better live weight gains, better conception, fertility type things. Also now we're playing around with certain species that can trigger certain things in an animal and or the soil, whether it be for milk production in lactating animals with plants that can trigger that to happen, stopping bloat, there are many things. So when we're doing these covers, we try and get as many species as we can. You know, chenopod's, brassicas, legume grasses. We need a mixture of warm season, cool season. So, you know, there's certain ones in the mix that we put in that are real heavy lifters that can provide really good benefits to the soil, and then also really good live weight gains. Some of the first times I really saw that collaboration, and as an example of that, but when we're, as farmers, we're sold products and fertilizers and seed and different things, most of the time we're told, look at what's plant available, what's soluble, what can the plants grab in the soil. And then, you know, if we're low in what's plant available, phosphorus or nitrogen, we need to put more on. But what we really need to be looking at is our totals. We do some total soil tests, measuring total active fungi and biology, and what's our total nutrient pool in the soil. And what we find, there's a lot that can be locked up or unavailable in the soil profile. Now, the only way to make this available is through biology, whether it be root exudates, releasing different compounds to solubilize and release these nutrients, or fungi, bacteria, other microbes and things. Now, this is a real example of, you know, this is buckwheat, like to show the benefits of how these plants can release and unlock nutrients and share. We harvested a buckwheat seed crop, and with the seconds grain that we had, I didn't want to throw it away, so we just put it in a front end loader bucket and spread it out in a layer across a multi-species pasture here. We had a couple of inches of rain not long after, and the buckwheat come up really fast in the autumn. They're quick growing in those sort of conditions. When we come into winter, it frosted out like really fast and hard. But what was really interesting, I could sort of see behind the boys there's a bit of a line. I don't know if it's coming up on your screen, but we had like about a half a foot difference in all the oats and the vetch that was growing there, of biomass increase. We're now using buckwheat. If we get early starts like we have this year, we can put it in as a companion to certain grain crops. And we're finding with very little P applied up front, we're getting this real flush of phosphorus and we can measure this in sap tests and things. So they're examples of plants that can release phosphorus. Also legumes, clovers, they've got a more acidic root exudate, kind of like when you've got calcium and phosphorus bonding together, like in, say, single super, and they put sulfuric acid on it to release that bond. Well, the clovers and things, their root exudates will trickle feed that constantly into pry apart that calcium phosphorus bond. Radishes as well, I'll talk about them. But so there's certain things in these mixes that we can really unlock and stimulate, you know, nutrients and disease suppression. Like oats release that compounds that inhibit diseases in pulse crops. You know, also take all in the soil. There's many different things. The brassicas can inoculate the soil from nematodes and things like this. So we can get the more the merrier in. What we find, you know, we've also got, you know, obviously the legumes fixing nitrogen. This is really interesting when we put, this is like a pea plant next to a brassica. when we find a monoculture of just all legumes and you've got good soil rates of nitrogen, they can be very slow to start forming nodules, you know, up to when the plants are starting to get a bit of size and they're looking for end. But if we plant these plants next to a scavenger, like wheat or ryegrass or brassica, they can fix up to twice the amount of nodules in the same amount of time. So I'll just talk a bit about, you know, paddock preparation and getting that right. So I think some of the, and like Luke said earlier about, you know, getting success and not success, it can be all how we, you know, get the plants established. So this is an example on our farm this year. So I'm not afraid to share, you know, things that we still get things wrong. We're still learning all the time. You can't get it right every time, but we do a lot of trials on our farm with different fertilizers, biological inputs, foliars, mixes, seeds, because we want to learn what can work and what can we use as tools to fix these problems, not just treat symptoms, but go forward. Now, we can do an easy approach and just put out a blanket rate of this and that and sort of address a lot of these symptoms. But if we want to grow and evolve and get better, we've got to get out of that comfort zone. And in the process, we're not afraid to have a few learning experiences like this, because this is how we grow and evolve and get better, and hopefully can share this on with everyone else. But this is an example of sowing. We find the best results is if we can sow these cover crops into, or multi-species pastures or forages or whatever, any crop you've got really. We just need to treat them like a grain crop. If we can sow them into, say, a nice clean paddock with a good history of weed management and fertility, like some cropping paddocks, and the crop comes up uncompeted, we can sow it in dry without a knockdown. We will have that crop come up as more the dominant and advantage. Any weeds that come up after that are less of a problem. But if that crop is sown into a paddock where there's existing weeds or a green tinge already starting to form on the paddock, if you think about placing that seed, whether it be a wheat plant, like in a monoculture, or a cover crop, by the time that seed germinates, if you're already seeing weeds that have got a green tinge on the soil, you know, by the time that seed, whatever it be, germinates 3 to 10 days later, by this stage, the existing weeds are another week or two above. They're starting to photosynthesize better and pump sugars. So these are guys that are going to be the dominant ones in the mix. And then you get the result like on your right, especially with certain weeds that can be allelopathic. They can pump out compounds around them to stop things growing around them. Now, you know, we've got to look at the ecology of our soils. And if you look at weeds, they're generally pioneer plants. You know, we can now identify, like this Cape weed on the right, generally as a low calcium, you know, calcium accumulator. So we could address that next year with some lime or calcium, and that can help mitigate that. But ideally, if we can get some sort of a knockdown on that, get the paddock clean, plant the seed in, we give it the chance to get away unimpeded. And that's the same, you know, in the perennial pastures. It's another tricky one. If we in the dryland loosen, I'll show you some examples later. They're probably the ones we've had the most success with, because they'll go more dormant in the winter, those summer species. If that paddock is sort of been pruned back, grazed hard, and the roots pruned, we sow it in dry before the opening rains, we've got a good chance of establishing that cover crop. But this year we learnt the hard way again. We'd had the opening rains early. Probably in hindsight should have come in with a you know, some sort of a burn, like just to set the weeds back with a light rate of Roundup or something like that. I'll talk about some options of that later, or just pruning it back with grazing. Plant the mixture in then, and then it's got the advantage of getting going. So the other thing we do, because we might put 400 or 500 hectares of these things in every year on our farm, we might start with our cleanest paddock. The first thing we sow in our rotation is a cover crop to get something going early, and then maybe the last paddock we sow might be a cover crop, and they'll be into your dirtier paddocks. So where we've had a paddock 2 or 3 years of cereals, and over the time that some weeds have started to accumulate, so we'll let those ones, you've just got to know your paddocks and what you're dealing with, because if you're going to sow these into a problem paddock that's very tight, compacted, you know, high weed, you know, so it's early on the succession, you know, with a lot of weeds, these things can be very good primers to sort of change it out of that, get more fungal happening. But, you know, we might have to look at some chemical control at the start to clean the paddock up. because I think then if we can grow a bigger plant, bigger biomass, we'll be able to pump more root exudates and do more benefit for the soil. So this is another example that of, you know, putting a diversity of things in the mixes. What we also find with this is as your soil changes, your soil structure, your fungi to bacteria, different things, more calcium becomes available from certain plants. But we might also see, like this is a 13-way mix where on the left you see just a really high density of the radishes there. The rest of the paddock they're sprinkled more even, but this is in a low depression, and it's very interesting. Sometimes the soil, you'll see the dynamics of weeds change every year. Like certain years, it's, you know, this type of weed is really prolific, and other years certain weeds. So it's really important that when we get these high diversity mixes in, they kind of will balance the soil out over time. That certain things, areas of soil will call for that plant, and then as that soil structure changes, whether it be compacted and more of the tap roots go, that's where a lot of the summer species we put in are very valuable. The sunflowers and things, they can get right down and open up that soil compaction. So it's really important to know that and give you the greatest success of it working. I'll just before I get onto this one, so another thing, am I back on there now, Luke? Can you see me? Oh, yeah. Yeah, so another thing I think is important tool that we should look at is one of these things. It's a penetrometer. It's got a gauge here, you can measure soil compaction. And what we see, like especially this time of year, July, coming into the spring, I'll get around a lot of crops in the area and different things and measure. It's a good tool to measure soil compaction and infiltration. And what we find, paddocks especially that have had a lot of random traffic, a lot of hay production on them, things like that, you can get there in July and push that probe in, and we might only get it, it's got measurements on it, you might only get it down, 30, 40, 50, 60 centimetres, and then I'm hitting, it measures a really high pressure. So once that pressure gauge goes over 300-400 psi, roots find it very hard to get into the soil. As over time, pretty well most all our paddocks now, we do controlled traffic and a few things like that. Once we get those tap roots in, they can go right down and open up that soil, get that air, that oxygen in there. A lot of the times you'll find that when we get into those layers of years of applying different fertilizers and things, a lot of them can leach through the profile and sit down there. So there can be a huge thing to tap into once we get it. But once again, this can take time. So we've just got to be patient. You could potentially come in and rip it, like some people might suggest to speed it up. But really, if we're getting that probe in 30, 40 centimetres, no worries, you're going to have to rip pretty far to get under that. Whereas, and it's going to cost you a lot of money. Whereas we like to use the plants, roots. My mate, like Vince says, roots not iron. Some of these plants can go down, 2-3 metres, sunflowers, brassicas, radishes, things like that. Open up the soil. And this is an example I got off a slide in the States. Those radishes, everyone start growing on them. They're a great plant to have. They'll send a tap root down. We've had them in, 2 or 3 months, done a soil pit and found their roots down 1.5 metres. But what they'll do, they're scavengers, and they'll go down. This is an example of phosphorus concentration around radish holes, but they'll also grab sulphur, nitrogen. They'll bring it up from the subsoil and they fill those big tubers up. And then, that's good carbohydrates, really good feed value to eat. But when those tubers, when they die and they shrink down like a carcass, they can inoculate the soil, but then they can redeposit and distribute all that phosphorus and things back into the topsoil. We've even been working with some radishes now that have been specially bred by breeders in New Zealand that have antioxidant properties. And when we trialled some this year, all our smart radish we used this year was like that. It's got the purple stem when it comes in, full of antioxidants. We had paddocks where we had the plain daikon radish in with the smart radish, and clients that have put sheep in, and they're just going straight for those smart radishes and smashing them and really eating them up. So it's really cool. Animals are a really good way to gauge what's going on. They'll pick and choose, and I'll talk a bit more about that grazing management in a bit. But once again, there's the example of those tubers. we found when they rot down, if you want to go fishing and find some worms, you go for one of those radishes, and the amount of worms that come up, they really prime the soil. They're good biological primers. We've found their tubers rotting down and just black. The soil turns black from worm casting. So a great plant to have in the mix, along with many others we get in there. Oh geez, my slides are a bit out of whack for some reason, but yeah, this is another example of oversowing a dryland lucerne. So we did a bit of a trial this year, or a couple of years ago, sorry, where we left a strip that didn't get oversown, and on the left of where I'm standing is we oversowed with a mix there. As you know, we only had about 150 or 70 mils that year, so dry year, but quite a lot more biomass production over the top. So really good, like I said, at priming the soil, adding things into these perennial pastures when they're dormant. We're working on a number of mixes now at the moment. One that will be a biological primer designed to go sowing over perennial pastures that will fill in the holes or the gaps that the perennials aren't providing, whether it be mustards and taprooted plants and different things that can sort of wake up those sleepy perennials. Also, you know, different starter mixes, high diversity, summer and winter, you know, orchard mixes. There's many things and uses we can do with these plants. Equine and even dairy mixes, and playing around. I've got dairy farmer mates here. We've got species we're in, and we can easily measure what we're doing as we're going forward, because especially the dairy cows, because it's instant in the vat. So there's certain things we can put in there now that can trigger, like I said, the lactation and milk production, and so really cool going forward. Oh, I've missed a whole slide on. Sorry, Luke, guys. I'll just stop sharing. For some reason it's gone back to here, but I was also going to talk just quickly. I had a slide here to show, but it somehow dropped out, on seed treatments and biostimulants for getting these things going. So one thing we do in the mixes is we always ask for seed that's uncoated or bare seed. We don't want to put any sides or fungicides and things, because it can be kind of detrimental to getting that rhizosphere really humming at the start. So we've got a number of things we can put on the seeds, whether it be legume inoculants to help with the rhizobia, or biological stimulants. One thing to keep in mind when doing these things, like Joel and Graham Satan and Joel Beyond, what these guys said shortly, is always try and put microbes, minerals and carbon. You know, if you can get that on your seed, it sort of sets it up to have it right there when it germinates. It's coated in, it gives it all that energy and stuff to get going. And same in the trench. So there's certain, like the products these guys use, the TM21 or germination, it's got all those things in there, the biological stimulants, minerals and carbon. You know, there's people can use worm juice. We've done compost extracts, made our own. Like a lot of these, there's the Johnson Sue, if people have seen that. There's many things we can do as farmers that can be quite low cost effective, and very important to set the plan up from the start. Instead of putting, like, we haven't used a seed dressing as such a fungicide or for more than 10 or 12 years on even growing monoculture crops. We'd rather put things on there that helps the plant grow and stimulate that. Also, like with fertility requirements, we've got it. We sort of always keep in mind the things that can help facilitate and feed the fungi. So, you know, ideally when we get everything in the mixes working, you've got plants releasing and that and sharing, and maybe when you're 2 or 3 years in, you know, we do it on our farm where we'll just put some biological stimulants, maybe compost extracts and a bit of liquid calcium or thing, and we can grow huge amounts of biomass very efficiently with low moisture. But there's sort of a transition and a process to, you know, I suppose you've got to earn the right to be able to do that. And if the soil's tight, compacted and had a high history of high fertility, you've sort of got to wean off that and then ease into it. And, you know, one way is going cold turkey, and that probably works more effectively if you've had a dry year, and so nutrients aren't the limiting factor. The other way is transitioning in, maybe just backing off it with a percentage each year. Now, if we are using those maps and single supers, if you can wrap them, coat them in a carbon source, liquid carbon. That will help buffer that effect on the fungi, but also stop it from locking up and make it more stable. There's other things out there, you know, alternatives like guano and things that are still addressing, supplying some nutrients in, but you know, more safer and softer on the soil biology, I suppose. Got to keep in mind these biological approaches, especially in our southern soils. If they are sown late, like if we sow these things early, March, April, and the soil temperature is warm, we can get that canopy up quick, and then we're starting to pump the sugars, and it can seem to work really well. But if we're sowing later down south, and the soils are getting colder, you know, sort of mid-May onwards, you know, it's like putting things in the fridge so that it slows down, you know, it slows down the biology, basically, breaking down the food. So if our soil temperatures are getting below 10 degrees Celsius, some of these biological approaches can slow down. There's ways we can sort of mitigate that. Foliar feeding, you know, don't be afraid to put some dissolved urea, add some humates. You know, it's a good opportunity. If we've got things that are slow, we can add some calcium and different things and some biological stimulants. Or yeah, just sort of addressing that. And as our soil structure, like I talked about, gets more open, more airspace in there, the roots and more fungi can get going, the less we have to do. Other things we use for the fungi side of things to help facilitate that, along with certain plants are very fungal, especially a lot of the C4 summer crop species. They also got an extra carbon molecule, so you know, they can pump more carbon in at depth. But we might use things like fish and humates down the trench with the seed or on the seed that can help feed the fungi. They're very good fungal foods. So that's a few things on nutrition. Now, weed management. This is quite important too. This is just a bit of an experiment we did with two paddocks side by side. So they were poor performing paddocks, and we basically we grew a series of winter multi-species covers followed by a summer multi-species cover. We did that for 3 years in a row. So it had living roots all year round, you know, through some dry years as well. But what we're trying to do is, you know, and we're grazing them and things like that. This experiment we're doing on the right is we had no weed control at all. So basically at the end of the winter cover, we just went straight in with the disc seeder and sowed the summer cover into it. And on the left, we came in and terminated that with a herbicide to stop weed seed set, and then sowed it with a summer cover. And we did that for 3 years, and I was sort of hoping that maybe if I didn't use any chemicals at all, we'd get some more magic or something happening. But it's sort of, and I mean, these are tight sort of sodic clays and things, but where we used, you know, we're just using a litre of glyphosate, and we put fulvic with it and humour and molasses to help that chemical break down. But by doing that, it allowed us to get on top of those weeds, and then we went back into an oat crop, and we had literally 4 or 5 times that photo on the left. We cut, that was last year actually, and I think we had 170 mils of rain, and we cut about 6.5, 7 tonne of hay off it after it had 3 years of winter and summer covers. And the other one was only, it came a bit better than that, but it was a lot of ryegrass and things. So really important to control the weeds in these phases. Eventually, as your soil dynamics change and fungi and different things, some of these weeds can disappear, but we've got to be realistic too and be profitable doing this. So weed control is very important. Now, I know some people might be organic, and so we actually look at ways that, what are other options we can control these weeds without a herbicide, and do a lot of experimenting with that. And this is another one that I find very effective. So this is the same year. This is on the back of, we had about 110 mils of rain in 2018. And we had a summer cover crop on it that summer. And then last year we grew a winter cover crop on it, had 170 mils, and grew, just amazing the biomass we got off that at very low input. But what we did is that we grew it through to milky dough, and then we dropped it for sort of hay. Now, years ago, I sort of went right off hay and straw. It was a sort of dirty word because we're so much, removal and that. But in this situation, none of this left the paddock. It only left it in the form of weight gains. So we dropped it down into windrows. Then we run a poly wire through, and we brought in a heap of weaner cattle, and we strip graze these windrows. Now, what we find is if we do have any, I really like this method because, one, we're not removing anything. Two, there's no baling costs. There's no lot of traffic and compaction happens when we're making hay, driving all over the paddock, pressing bales, stacking bales, and trucks getting them off. This way, it's just one pass, drop it. If there's any weeds that regrow, when you're making hay, you've got to wait 10 days, 2 weeks for it to dry down to get it in the bale, then to get it stacked off, then to get back out to spray those weeds. By then, they've a lot of times set seed. This way, we have the animals in there, anything green that reshoots, they can nip them off. So we found this is a very effective way for weed control. Some people will say, oh, what happens if you get rain? But probably to our advantage in our summers, we can get 2 or 3 months of pretty hot and dry weather. We don't have to wait, like we're putting the cattle in there the day we're cutting it. We can find that you can get 30 mils of rain, 40 mils of rain on that. It's not too detrimental if you've got good soil structure and quick infiltration. That water will run through that windrow, go in. It's when you get 2 or 3 rain events that can accumulate and potentially get some damage under the windrow. But, in that case, we can always flip them or rake it or just send more cattle in. But these are just things we're experimenting with to get, weed control without the use of the chemical. And turning that into live weight gains. Now, in this situation, like when we're harvesting grain, we remove like up to 50% of our biomass. Cutting hay, you remove everything. This way, most of it's just cycled straight back out through the animal. And we measure, dry matter cuts here. We'll measure weigh the animals going in and then weigh them coming off. And so we can sort of see what's been removed. And a lot of it's, maybe up to 20% max is removed in the form of live weight gains. So a lot less than actually growing grain. The other thing then we release, dung beetles, things like that. We can grab that manure, get that carbon down into the soil profile and kind of build some carbon at depth real quickly. And this is an example, some of the cows, what we're finding in these multi-species mixes, because we've got that diversity of everything, we've done live weight gains on this windrow strip grazing, on grazing the covers, on bale grazing hay, and we're finding really, really good live weight gains. We're weighing our cows and calves. The cows are putting on heaps of weight, and the calves as well, and animal temperament, fertility, joining issues. There's lots of benefits there, but this is what we like to see. Most of the time, they don't take long to get their gut filled. Like they seem to go in, have a feed, and bang, they're laying down half the day. And I think that it all comes down to nutrient density as well. If we're juicing these crops with heaps of nitrogen and we're filling these plants up with a lot of nitrates and water, there's less value and less nutrient density in there. We're finding with these multi-species, they can get their minerals and nutrients way easily. Then they're just putting onto live weight gains. The other thing with yield wise, when you look at some of these things and try and assess yield, because you've got different levels of, vetches and clovers down low and oats and things up high, it really bulks up the mix. So quite often people can be quite surprised when you get some cuts on these, what dry matter you can actually produce. Like I said, in managing these things, one way we can harvest our crops is with a big depreciating asset on the left there, or in the middle, we can use an appreciating asset four-legged animal harvesters. And we monitor everything we do, whether it be yield monitors in the header or yield monitors in the crush. Then we can fine tune what we're doing and make steps forward to improving things. The grazing management, I'll just touch on a bit here, which is some interesting trials we've sort of seen and done. Last year we had a dryland loosen paddock that we oversowed with multi-species. We split the paddock in half with a steel wire. Like when we're mob grazing and strip grazing, 130, 200 hectare paddocks. So we've now a bit more work and that involved, but once you get it worked out, and we can talk a bit about that, it's what we see that the grazing impact has is another real key to making this work. And you know, the animals can, in that tugging and chewing and trampling of it can really prime the soil that creates the plants to release more sugars and root exudates, then in turn to feed, you know, back into the soil. So last year, where we might cut a big paddock in half with a steel wire, and then set up poly wires. If I've got like this on the motorbike, we've made one up here, a little reel. We'll run that out now. That paddock last year, where we cut it half with steel wire, one side of it we didn't touch till about October, when it was pretty well ripe and mature. The other side we back grazed through the winter. So they were effectively getting, and we measured the live weight gains, and it was really good gains. But then we pulled the steel wire down and just let them into that higher side, which was a lot more, you know, it's all gone milky dough and mature. So there's probably a lot more trampling and a little bit more wastage in terms of what we've grown, but we still converted, you know, the animals did really well. But what was interesting, coming back the next year later, which is this year, we can go into that same paddock and I can see to the line where that steel wire was, and on the side we grazed late, we'd have up to 2 to 3 times the biomass the next year versus where we've grown it and grazed it through the year. So what's interesting, you know, we've got to feed our animals and they've got to eat something. But the next year we might swap that around and do it the other, you know, graze the other side first. But by grazing it as it's growing, you're effectively leaving less cover and you're pruning the roots. And I think from when we can let these plants get up big, and they don't have to all be big, but we've allowed the roots to get down deeper into the soil, you know, help break up that, you know, subsoils and get more nutrients out of there up into the topsoils. But all that trampling and cover, you know, we've got to be mindful of how we manage these things, because what we see is sometimes a bit of wastage, you know, this year. It can come back to be a massive gain the following year. So that's another thing to think about. These are some examples where we've done some bale grazing trials where we might have, you know, some areas that are high weed burdens, and we might just bring in a whole heap of hay and cut the strings and let the animals in, and they'll trample and waste a bit of that. But some of those areas, well, this is an example there, you know, we've put the header through growing barley crops and that, we can get 2 to 3 times the yield the next year just from that mulching effect and trampling. So very interesting there. The other thing, I'll just get onto summer cover cropping, and this is something that it can be, depending on where you are, whether you're in a high rainfall area or marginal or not. For us here, it's sort of opportunistic. We've done a lot of big areas on thinking we're going to get 40, 50 mil and got 5 or 10 and had pretty limited response or success. But then there's been years where we've had really, really good results from some summer cover cropping. So this year on the left, we're actually sowing into a terminated winter cover. You see the cereal rye and that's on the right after we've sown it. What we've found for us here to make this work, if we can go in and know we've got a bit of stored subsoil moisture, so particularly after, like in that situation where we've cut it for hay or something like that and the crop hasn't ripened, or we might have a paddock that we've carved on and then sprayed it out and we've got a bit of stored moisture. If we can get these summer covers germinated and with a couple of inches of rain, then that, you know, you think about birds and some of those other tap-rooted plants, if they can tap down into that, you know, particularly this year, if we get a La Nina year or wet year, that some of them are saying, whether we do or not, but having that seed, being able to get it in there quickly in front of something like that. On the right, that year we had about 6 to 8 inches over the summer. We had millet, sorghum, corn, sunflowers, things like that. We bought about 200 young, 160 kilo animals. That year was actually a really dry cropping year. So some of these times it gets you back in the game. You know, you might not have much off the winter rainfall, but if we can get the summer rainfall, when we're just full cropping, you sort of, you know, that ends up just being, you know, spraying weeds and doing all that. If we can get these summer covers in, we ran these cattle, they were 160 kilos when we bought them. put them in on Melbourne Cup weekend, ran them on these covers over November, December, January, brought them back in, reweighed them, they were 320 kilos. So we did, you know, doubled their weight, over 120 kilos in 120 days, so the live weight gains. So, you know, the price of cattle at the moment, there's some real good opportunities. The other thing we've found with these summer covers, you know, if we want to break up that subsoil, these are probably one of the best ways to do it, because their roots are just like a sorghum or millet plant. If you dig under them up, comparing to a plant of wheat, the root system on them is kind of chalk and cheese. They're massive root systems. They feed a lot of the mycorrhizal fungi. Some of these plants, it can be a real good primer to get it going. And a lot of time in our environment, we kind of, especially here, it's all dominated by winter species. We're looking at feeding the soil, which is what these plants do. You know, we need a bit more of the summer species in there, and these can be ways to get them in. You know, for us here, it could be a bit more risky to try and grow actual summer grain crop, but if we're just growing it as a forage, it can be low risk, low input. We can still get the diversity of roots and really good live weight gains. And, you know, things like sunflowers we love with the taproot, they're really good at bringing up calcium and zinc. They're an oil seed, so when the cattle eat them, they're high energy. They don't have to crack the seed like most other grains. They can get some real value out of it. Yeah, so these are all little things now. Keeping in mind what we've found now, how do we manage after these summer covers? So, because one thing I see can work well or go extremely bad is following them with the monoculture the next year. Depending, like I said, on your environment, if you're in a situation where you have waterlogging issues over winter, you know, you're in a high rainfall, or your soil doesn't drain and infiltrate properly, these are no better, you know, really good way to open up and drain that subsoil out and allow better infiltration, better recharge into those soils. But if you're in a marginal area or a dry environment, this can be, you've got to manage these wisely and carefully. So we've found there's a couple of options. It's all about species selection and termination. So if you're worried about a dry season following a summer cover crop, we might terminate them before flowering. Once you get the flowering and grain fill, that's when they're ripping all the moisture and the nutrients more out of the soil to fill grain and go reproductive. So if we shut them, you know, we might even just grow them for 6 weeks or so. And that's enough. A lot of the root exudates and the goodness that they do to the soil is actually in the first vegetative stage, when they're sort of trying to recruit biology and they're pumping sugar and carbon into the soil. So we don't always have to grow them to massive big things. If we want to essentially build long-term carbon in our soil, we need living roots, because we've measured on our soil, we could get them up to 2% organic carbon in a cropping system and do stubble, retain stubble, all sort of best sort of practice. But if we get summer rain and we've got no living root there, and the biology wakes up and wants to feed, it feeds on carbon. So if there's no living root pumping carbon into the soil, they will start feeding on our stored carbon. And that's when you get that rotten stubble syndrome. The stubble snaps off because they've pruned that. So if we want to essentially build carbon, we've got to have these living roots pumping it in there. So one way is terminate it, like put them in while there's moisture in the topsoil, and terminate them before they drag the subsoil moisture out, if you're worried about that. Or two is choose species. We played around with low water users that are shallow rooted, that will stay alive, pump carbon, pump nitrogen, like cool season legumes. We've done experiments on them where we've terminated half the paddock and kept it as clean as a chemical fallow versus a living root, and done soil pits on them in late April just before cropping, and found the same subsoil moisture underneath it. So it's about knowing what species to use. Or failing that, sometimes we've got a paddock that's got tight, compacted subsoil layers. I'll let it go down, open it all up with a summer cover crop. Then what we'll do is, if we follow that with a multi-species winter cover crop, we've got a greater success of that working, and somehow we've got a greater root system, more plants, and there's more chance we can then just graze that, and we don't have to take it through to grain fill and then recharge the soil again.
Yeah, Grant, just let you know, we've got about 10 minutes.
Yep. Yeah, righto. Well, all right. So we can probably jump into. I was going to show, well, the photo for some reason when I've saved it onto that other computer, I've missed that. What I was going to show with the seed inoculants and biostimulants, which I had a photo in there, and you've probably all seen them, of a root system of a plant. I might stop sharing. That is kind of, if you'll see, that's got all the dreadlocks on there. So what we want to see when we put these inoculants on is, the dirt sticking to the roots, and it creates that, what they call the dreadlocks or whatever. Now, this shows up really well in lighter soil, sand and loam. So if you've got a heavy clay and it, sometimes the soil can stick to the roots and pull off, and you don't see it as effectively, but that's really what we want to see. I've seen plenty of roots and that we dig up, and where they've had a band of maybe urea or MAP at a high rate, and it actually there's no fibrous roots around it. It sort of burns them off. So what we want to do is encourage roots, and this is where these things can be a really good tool to get that fibrous roots and get that exploration happening in the soil. So yeah, that's something to look for. And also the other thing I'll touch on with the fertility and stimulating, because there's a lot of products out there. Essentially, we like to carry a brix meter around, a refractometer, and measure the sugars in our plant, all our crops, multi-species, any crop. And sometimes we want to, whatever we're applying, whether it be a herbicide or nutrition to a plant, we want to test before and after. And what we want to see is a positive rise in that brix. Because if we can get that brix up higher, it makes it, all of a sudden we're photosynthesizing higher, we're pumping more sugars, carbon into the soil, lessens our chance of disease, frosting, insects, things like that. We've had plants before brixing really high and had like frost events like we're getting now, and had zero damage, and then measure the crops with very low brix as their freezing point changes, insect pressures change with all that. So that's another thing we can look at. Did you want to jump into any questions now, or?
Yeah, we've got a few. So we've got, I think we've answered probably the first one that was sent through in the email about the untreated seed. We can, yeah, that's obviously available. Because this person, Daniel, he's bought a mix, and it's been treated with fungicide already. And he was just wondering whether that was a bit counterintuitive, because he was trying to grow his mycorrhizal, and whether there was untreated seed available. So yes, that there is, isn't there? Plenty of that.
Yep.
So, and Daniel, if you can't find any locally, just get onto us and we'll get it sorted for you. Righto. The second questions, rules applying when designing a cover crop mix, and the intersections, and where do you find information about what the different species do with each other?
So there's kind of, just basic rules of thumbs that we use, to get plant densities right, that we use formulas so that we're getting enough of the species there. And there's data. The South Americans have got, probably the started a lot of this, and I'm lucky I've got sort of contact with some of those people, and even like in places in Germany, they've been doing it 90 years. So there's certain ratios that they put things in with brassicas and legumes. It's kind of like, I've heard it described as like making a spaghetti. So you've got your pasta and your meat and your spices. So you kind of don't want to overdo it. But then with certain things that can outcompete, a lot of this comes down to just experience and finding what works in different soil types and locations. And that's where it's tricky, like from southern soils to northern soils as well. Like in our summer mixes down south, the tropical legumes, I think we need to introduce the rhizobium or inoculum for a few more years to get them. We've got them nodulating some species quite well. So there's certain things there that we know, that are going to work in some soils better than others. And, I'm pretty lucky. We've got, we went over to America and went through green cover seeds, and Dr. Jill Clapperton's been helping us out a lot. She studies the rhizosphere, or the root zones of plants, and how they interact. So there's lots of ways we can fine tune and make sure we're sort of getting it right. Because, they say for sort of that quorum sensing and that magic to happen, we need 8 or more species. But at the end of the day, like, we see big benefits just going from one, like say a pulse crop, to 2 species. Putting a companion in helps with disease. You know, 2's better than 1, 4's better than 2. So sometimes it might be just, you know, ease into it with a couple of species, and then as you get going. But a lot of our mixes have been in a few trials this year and done quite well with live weight gains and biomass. So when we get them all in there, a lot can go on. The other thing I'll just touch on that, because I've got those questions, is the perennials. So depending on, like I was saying, the succession of your soil, we might start, if it's, you know, a lot of the cropping and practices we do tend to turn our soils more bacterial dominated. So sometimes we might have to prime them with annuals, which are fast growing and generally cheaper seeds, so we're easier to get more diversity in. And then, you know, do a bit of a program, year 1 or 2, straight annuals, year 3, stitch in a few perennials, and then you can get to a point where you can just have a diverse perennial mix. But, you know, we've got to make sure our soils are in, we don't want to jump steps, because if we've got perennial pastures full of weeds, well, we've got some issues that we might have to prime them and address them with annuals first for a bit.
Yep, excellent. The next one I get asked quite often, what about equipment? What's the best equipment and that sort of thing that you've found?
Yep, good question. So seed placement, we've found we use a disc seeder for low disturbance, and we've seen, like, my old man and his brother, they started direct drilling or no-tilling in the early 80s. And we saw really good gains to our soil structure and physical aspects of that. But when we went from a disc to a tine to a disc, that's when I started, like, we could get the shovel in the soil and you dig it, and the top, you know, 2 inches would be all crumbly and it would crack and there'd be a line, and the bottom of the shovel would be quite platy and compacted. And that's that tillage pass of the tine running through, breaking up that soil aggregates and the fine particles, then when it rains would, you know, accumulate and give it that dense layer, that subsoil layer. When we go to a disc, low disturbance, we get less of that happening. And after 4 or 5 years, now we're finding you put the shovel in and the bottom of the shovel is just really crumbly, and you know, you can't tell the difference between the top and the bottom. And that comes in real important when you are trying to capture and infiltrate water, because obviously the best time to have a look at infiltration in the summer, you get an inch of rain, wait a day or 2, go out with the shovel. A lot of time you put it in and you'll see the top fairly wet and the bottom of the shovel bone dry, because it sits on that plough pan layer. Then you get a week or 2 of 30-degree weather, you've evaporated, you've lost that moisture. So if we can get it in quickly and deep, then get a cover crop on that, get canopy closure, we can keep it in. Really, water management is all what this comes down to, because we can lose water out of our soil 3 ways. 1, it just runs off, which is the worst. 2 is it evaporates out. And the 3rd way is we can transpire it out through a plant. And that 3rd way is the only way we can make money. So disc seed is low disturbance, really good. We have seen, I get asked sometimes, broadcasting seed. Certain seeds really work well with that, particularly the small seeded stuff. Like, you can pretty well have canola and clovers and things in the yard, blow on the ground and nearly sneeze on them and they'll start growing. The small seed, they'll get growing easier. Some of the larger seeds, you have more success. You know, I always think placing the seed gently in the soil is best. I've also seen people quite successfully have like a winter cover crop, say, and they've had it, you know, growing up quite large, go in with a spreader and flick millet and those small seeds out, and then bring in large numbers, huge numbers of, like, sheep especially, but cattle as well, with their little hooves, and then they sort of trample the seed into the soil as they're grazing, get a summer rain. So they are certain things in our mixes will drop and set seed and re-go, and you can use animals as a tool to do that. But generally, as a rule of thumb, we find low disturbance is a good way of doing it. The sort of only thing in that is if you have perennial pastures, sometimes like maybe the soil key renovator or some sort of in-row, like a strip till type thing, to let that plant get established unimpeded could be a good thing as well, potentially.
Yep, excellent. No worries. Seeding. So seeding rates, would you change the seeding rate if you were going to broadcast or drill?
Yes, yep. Generally, as a rule of thumb, if you're broadcasting, you have a lesser chance of success, so you might increase your rates. It's something we're probably going to look at now in these mixes we do, is having a kind of a range to sow it between this and this kilo, because probably more in a marginal area, or high rainfall area, those rates can change a bit, or warmer soils and cooler soils can change your rates a bit, and broadcasting and sowing. So that's something we're looking at. But generally, if you're broadcasting, you probably want to get a little bit more out there. Definitely, to increase your chances of plant density.
Yeah. There's quite a few here. Malcolm, I think we might give Malcolm a call actually, because he's about 10 questions here, so might have to have a chat to him. So we'll get into some of the questions of. We've got one here. Are there any peer-reviewed papers on the benefits of multi-species cover crops that you know of?
Well, yeah, there would be. I don't have any links or that off the top of my head, but I'll grab a few and put them up. Know, them available for you, because there's plenty of work done all around the world on this. I think if you looked up Christine Jones or Joel Williams, or they'd probably have something on there. Yeah, I know Jill's done, Clapperton's done a lot of work.
Yeah, for sure.
And the French and the Germans have done a lot as well.
Yeah, so David from Two Ridges Farms, he doesn't use any chemicals at all, and he was just wanting to know. We've gone into the question box here, so it's he doesn't want to use any chemicals, but he's got a perennial pasture. Phone's ringing from Lismore. Mate, got a perennial pasture. So what's his best bet? Just go in there and graze it heavily, or wait till the perennials go dormant before he sows? What's
they're probably the tricky ones. I think a heavy grazing to prune the roots and give the annuals a chance, and maybe some, if you can do a little bit of like in the placing the seed, it's sort of, whether it be a tine or whatever, does a bit of mechanical disturbance to give them an advantage. There's also certain species that'll grow quite successfully in there. So that's where we're looking at this biological primer mix to make sure we're getting things in that are going to compete. And it's sort of knowing what species. And like you say, waiting for dormancy is a good way too, of the summer or winter dormant. Put in the other species then.
Here's one. Beneficial insects and pest control side of things. So and for pollinators. So how long should you leave your cover crop in to get those benefits? I suppose flowering is the
a lot of them. That flowering in late stages is when you'll have a lot more diversity of insects and things come in, and it's amazing. Certain plants like your buckwheat and any of those flowering plants, crimson clovers and things. We've actually got a pollinator mix that we're trialing at the moment, but getting that diversity in, there's the parasitic wasps and things like that can come in onto these buckwheat flowers. They love them, and then they can feed on their larvae or feed on aphids. It's that whole sort of cycle. Spiders, a number of things like that. That's where choosing mixes like that in the interrow of grapevines and things where you're getting certain insect pressures, we can know that we'll find out what's the predator to that pest, and we can plant a plant that will attract that predator in. It can take a little while for that system to build, but if managed well, can be quite exciting. And there's a lot of data out there. I could get some papers on that too in some of these sides, now that you're using for managing insects are either becoming banned or they're becoming less effective. The insects are building up resistance to them, and there's probably going to be a point of time where either the chemical doesn't work or we're not allowed to use it. So I think if we're on the front foot and we've got habitat for these spiders and things to come in, it's a sort of win-win for everyone all around. And just focusing on nutrition too, really. Like a lot of times the pests and insects are there because things are way out of balance, you know, and there's certain chemicals that can shut down certain minerals within a plant, chelating them and making them unavailable, which then brings in more susceptibility for disease and or insect pressure. So we really focus on getting that balance in there, and a lot of those symptoms start disappearing.
Yep. And we got one here. Can you successfully harvest a multi-species cover crop?
Yes, yes, you can. One way is, like I said, with a four-legged harvester, an animal. That's a real good, successful way of harvesting. Or, yeah, we've done hay. We've cut it for hay and had them feed tested and had, you know, because you obviously got, it's a, you know, you get your vetches and your clovers, so good protein, and you got your grasses. So that's another way. But as far as harvesting, which I'm sure the question was aimed at as for seed, we have done it. I've scared the heck out of me seed cleaning man to see how you can go getting all this cleaned up. But it can be, once you get over, if you've got 2 things in the mix, pretty easy. 3 things, not too bad. Once you see getting into high diversity mixes, you can do it. And if you're just going to do it and sew it back on your own place, well, that's probably, you know, going to work. It's pretty hard to get your settings right and all the different pods and residues and things out. But it can be done. But what the other thing is, you lose control of your ratios, because certain things as they mature might take over and dominate. And if they're not in the right ratios, then all of a sudden you have all these tap-rooted plants winning and dominating because they're dragging on the moisture at grain fill. So, yeah, it can be done, but it just depends how successful you want to be at doing it and what control. You lose control with what you've got.
Yeah, yeah. Here's one. How do you find that the summer cover mixes germinate into the residual of winter crops still so high?
Yeah, we've had mixed success with that. We've done some sowing green trials, and we've done some where we've sprayed it out and then sowed. You've got to be careful, obviously, what chemicals you use there, that an emerging crop's not coming up and getting tangled up in some residual chemical. You know, crimp rolling, there's a lot of people that have good success with that. It really depends on your moisture and, you know, in your soil and rain. Like in the States where they do it, a lot of the places they do that are in more high rainfall areas. Like we're over there, and a lot of them, you know, they might be 400 mils a year rainfall, but they'll get it, you know, 100 mils in sort of in their, you know, in their spring through to summer. So they're getting, you know, a lot of rain when we're getting that to work. So it's a little bit different environment and rainfall patterns to what we get here. Yeah, so it can be done, and laying that mulch down can be very effective. When it works, it can be really good, but I'll just be cautious. Don't do, just experiment. Anything like this, it's always best that you know what works, do that, and then just try small areas. And then once you work out, because sometimes it can take 2 or 3 goes to get at it, you know, to get it successful. And, you know, what works this year might not work so much well the next year. So,
yeah. I think we've already touched a little bit on this one, but yeah, pest management and weed control, especially in autumn sown covers.
Yeah. So that's where I was saying earlier, like weed control is a real tricky one and you've got to know your paddocks, like, because obviously once everything comes up, you've got limited herbicide options. We did trial this year a chemical called Igran that takes out cape weed. It's registered, won't touch any of the cereals or field peas, some clovers, but it might take out your brassicas and touch up a few vetches and things. So there's some options, but they're quite limited. So, you know, if it is a weedy paddock, generally it's quite important to get a knockdown first. You know, and then if we are or sowing dry before the weeds come up, and like I said, putting that inoculant on the seed, giving some pop-up biology and nutrition in to give it an advantage over the weeds. And then insects, I mean, there's, you know, a number of different ways, but we find like we've had quite good success with applying liquid calcium on cover crops and monoculture crops. It's very good at lifting sugars and initiating sugar production, and in our clay soils generally calcium is something that we're always looking for. So sort of knowing what it's handy to have sap tests and that, so you know what can be unavailable or hard to get in the plant at times, and look at whatever the lowest mineral is that you have, address that, and that generally will pick your brix up the best. The other thing I didn't touch on before on the fertility, which I've done a lot of trials and experimenting with, because we've, some of our ground we haven't had MAP or single super or anything like that for over 12 years. And then we trial it every now and then in little strips against the liquids or the more biological things we have. And what's really interesting is a lot of times in some of those MAP crops, we'll sap test them now or in, after touring later in the year, and we're finding below average phosphorus in the plant, even though we put quite a bit on at the front. But in some of the biological crops, we're sap testing them and finding average to above average P in the plant, even though we might have only put small amounts of P, like in a biological form up front at sowing. And what I'm told is happening there is fungi. Fungi's in the system. Once fungi kit's coming in, it'll keep solubilizing phosphorus and trickle feeding it into the plant. So that's kind of how we want to feed these plants, not with a big flush of everything at once. They will just grow differently. But if we can get our sugars up, our brix, by addressing our limiting nutrients that we have, and or some biological things like kelp, seaweed, fish, these guys, the TM stuff, like that can improve the health of the plant, so then it makes it less likely to get damaged by insects or diseases.
Yep, excellent. The John Strad Sioux compost extract, do you sort of understand that, or? Yep. No, I met him a year ago in the States, and amazing. I saw him, amazing things what he's doing with that, and I rang quite a few different people once I saw it and talked to him, that different scientists, and was like, is this thing for real or what? This is unbelievable. And I think it's amazing that this is something that we as farmers can go and set up in the back, behind the shed, and get it going, and then it costs you next to nothing. So at the end of the day, if it doesn't work, you haven't spent big money on large areas or whatever. But if this does work, if we're able to get it happening, it's quite an amazing thing. And there's a lot of research, out there, and they're over in the States. I know they're all trying to prove this wrong in certain areas, saying, oh, it'll only work in this soil. But from what I can understand from people over there, that where it's been applied, it seems to be working quite effectively. And basically the seed germinates and thinks it's in a highly fungal environment, and it sets the yield potential. And I think we've lost, the genetic potential of some of our plants has been potentially compromised. So if we focus on stop killing things and how do we make things grow better, we can really unlock a lot of the magic that happens. And a lot of this is, even the world leading experts, they still say we're only at a small percentage of what we actually understand and learn. So that's the tricky thing. But that's the difference I see over there. There's a lot of research stations that are implementing this, getting it to work. Farmers, a lot of this research is all done by farmers, and then they research and get it to work out there. So no, I definitely encourage anyone to have a go at those things, because they can be quite valuable. Excellent. So we do have quite a few people who have got small acreage, and they're just wondering how they go about seeding in small acreage, because they've got no equipment. So
good question. Like, there is small plot seeders and small equipment out there, but they're probably quite sought after and hard to get. So ideally, it's looking if you've got other neighbours or people around and you can use on. Like, we do a bit of contract sowing for neighbours and dairy farmers and things, and get gear in there. But that's always a tricky thing on the smaller scale. But potentially, using livestock or broadcasting is another way. But it's ideally if you can get a contractor in, is probably best.
Yep. Average brix readings in a season is a question here. I suppose the best is the higher you get, the better.
Yeah, definitely. And I mean, Brix is a funny one, and I know when I was involved with Vic No Till, we did some full art. We got some good articles on that. Talked to some of the real experts in using them. It's a good tool to have and to play around with. It takes experience and practice because you're going to have cloudy days and the Brix won't be as high, or frosty cold days. You can use it to measure, like essentially what you want to see is your Brix, low kind of in the morning and high in the afternoon. And if that's going up and down, that's the sugar flow is happening. If it's not going up and down, generally you've got the boron deficiency, because boron's sort of the trapdoor that allows that to happen. You can measure potassium from old leaf, young leaf with a Brix and see variances. There's little things you can do with it. But, as far as like feed quality and live weight gains, a lot of people, it's known for years in cutting hay and things, cut it in the afternoon, you got a higher Brix, you get better quality hay. I've got, seen data out there to say a 1% rise in Brix in a dairy situation pasture can equate to 100 grams of milk solid per cow per day. So, I mean, these can be a huge way where you can just lift these few little things, stimulate the plant and get massive gains out in milk production. And I think it's like 400 grams a day live weight gains. Like you can get, just by having that higher Brix can equate to greater gains. So as long as the health of the plant and insect pressure, so there's lots of, you just got to get playing with them all the time, and different weather conditions can change.
And also, when you do a foliar spray, how long after that should you do your Brix test? I've always been told about 2 hours.
Yeah, that's probably, like I've seen it within an hour. I've done things where we've measured the Brix and it's been 10 and we've sprayed a certain thing out and then measured it again an hour later and it's 5. And I go, oh, I probably should do a bit less of that. That's not a good result. But we've had the other way where we've measured things and they're 10 and we've foliar applied some nutrients and biology and got it up to 15. So I think some of them say within an hour to 2, 80% of that can be, into the leaf very efficiently. But yeah, and then the rest can take in over the next day or so. But it's a really good thing to play around with, the Brix, and that penetrometer and a shovel, I reckon, are 3 tools we should all have in our ute. And even I reckon another good one is a soil thermometer for the temperature, and just to see what's going on, because we really see you get a bit of nice warm weather, soil temperature warms up, things can really start jumping out of the ground.
Yeah, absolutely. And I quite often carried a thermometer with me as well. I took some temperatures on bare ground last year at 75 degrees during summer. So, and then I stuck a meat thermometer into the soil and it was nearly 60 degrees, about two inches down. So doing a...
Yeah, and that comes, it's good you raise that up. We did a whole article on that a while back, and that's the importance of ground cover. Like in our summers in Australian soils, we can get that hot baking sun, and we've done experiments like you say on bare soil up 60, 70 degrees under a heavy strip of stubble. We might be 35, 37 degrees, on a 43 degree heat day. Under a living cover crop, we might be back down to 25 degrees in the soil. So we've got to think about if in your soil, the biology, where all the magic happens in that, especially in that top 4 inches, that's where all your fence posts rot off in the soil because it's the most active of biology. And they always snap off there, and the bottom of the fence post is always good. In that top layer, people say if your biology can go dormant and sit there or whatever, but if we're hitting soil temperatures of 65 degrees and above, that you're killing biology, because there's a graphs out there to show different species die out at different temperature ranges, but basically you go to the footy, they cook your pie to 55 degrees above to make sure they kill the bacteria and we're not getting sick when we're eating some of these foods. So, you've got to think, if we're doing that, what's it doing in our soil? So that's the real importance of cover, keeping that biology alive and protected.
Yep. There's one here about Brassicas, and do they have an antimicrobial mycorrhizal impact in the mixes? Sorry, I've got something come across my screen. I can't see.
Right.
So yeah, in Brassica component in the mixture, considering there's non-symbiotic relationship with them, and also due to their biofumigate nature.
Yep. Yes, and that, like, brassicas are a non-mycorrhizal host, and there's a few plants out there that are. So that's why it's important, you know, especially if we're growing canola as a monoculture. You've got a non-mycorrhizal host for the whole growing season. Then we harvest that crop and chemical fallow it over the summer, and then we go into another crop the following year. We've had 12 months with nothing hosting mycorrhizal. So that's where we find it very important to put companions and things to carry that through. But, you know, it's all in moderation. Like, if these things are used at a small percentages in the mix, they can be very beneficial, like, you know, treating some nematodes and fumigating some of the soils. But if they're depends what you do. Like, certain situations in front of potatoes, they might sow mustards and things at a high rate for a purpose to fumigate the soil. But in most cases, we find, you know, a little bit of everything. There's certain plants in the mix even that, if eaten on their own in a monoculture, can cause issues, whether it be bloat or different things. But small amounts in a mix can stimulate and have a positive effect. So it's probably like anything we do. We do too much of one thing and overindulge, and it can be detrimental.
And other thing, different inoculants. Have you found that you need to use different inoculants for the different legumes that you put in your mixes? What we have noticed this year when we've been digging a lot of the cover crops is we've put no legume inoculant on, but everything seems to be nodulating and doing quite well. So
Yeah, that's a good question. Depends on the history. Like, if you've had a history of cropping, and like, there's certain legume species, and you can get charts to show you all this, that like beans and peas and vetch and things might be whatever group it is, the group F or whatever, I can't remember off the top of my head. And then clovers might be this, and there's certain clovers need this strain and certain that. So if you've had a history of using some of those inoculants in the soil, when the plants get in there, they can repopulate it and get going. Sometimes, if you've never had that history, it doesn't hurt to put them in. They will all, you know, eventually accumulate them over time, but it could take a couple of years. So that's where it can be beneficial to put some out with it if it's a crop for the first time. I know an instance where in North America, talking to some of the scientists over there, when they introduced soybeans for the first time, they actually inoculated the wheat with the rhizobium for the beans prior to establishing the beans. So it was already in there. You know, all those inoculants or bacteria can survive on any plant as a host. So it doesn't actually have to be on that seed. That plant can host it, get it in the soil. Then when the bean comes in next year, bang, it's already there and growing. So, you know, sort of build it, they will come. If you get them in there, you've got to be mindful of pHs and things like that if you're doing it in liquid forms, because it can kill them as well. But yeah, they will come in eventually over time, but you can speed it up and inject them in there or coat them on the seed.
Yep. Yeah. Well, what we've found is just by using TM this year, we've been able to get it to work, no problems at all. Seeding your multi-species, should you do it into separate rows or just mix them all together and put them out? Does it make a difference?
When you got high diversity mixes, it's pretty hard to put them all in separate rows, because that'd be a bit of a challenge. So generally, you know, if you're companion cropping and intercropping just with two species, which a lot are doing, and we do a lot of that, alternate rows are very effective for disease type management. Yeah, but it depends on the situation. In a multi-species, I think them all mixed together, you've got the roots all tingling and intermingling quicker than when they're all, you know, around each other. It really depends on, there is some benefits of having them separate, but it's more so in a more, you know, cropping type sense where you've got one or two species.
Yep. So we've just got a couple of minutes left. Is there anything that you would like to really point out, or that you think is really important?
Yeah, look, I suppose it's just, you know, being mindful of this. Like, you know, sometimes you can see, and I've seen different presentations on different topics, and you then you can get pretty excited thinking, right, all I've got to do is this, and it's all going to, there's no real silver bullet here. Like cover crops and multi-species are a really good way, and we've used them really well in rehabilitating poor soils, but it can take time. You've got to be realistic. Don't be disappointed if year one it doesn't work out as good for you. Even if everyone's read Gabe Brown's books and those guys that have been doing it a long time, they said year one it grew up to their knees, year two up to their shoulder, waist, and so when we've tested that with fungi and things, that you get kind of a compounding effect. And I mean, if you've got tight compacted subsoils, it might take a couple of years for the roots to punch in, and once they start opening up and releasing nutrients, then all of a sudden it can happen. So just got to take your time with it, and also be mindful of, at some point, if you keep doing certain practices, it's a bit hard at times to have a foot in both camps at some point. Like if you're going to keep putting a fungicide on where you're never going to get that benefit. And I know of some real leading agronomists in these fields sort of say one of the most important or first thing to go is fungicides. They've got to go because, they see that really important in making this work. So just be mindful of, what can be detrimental or unwind it, but don't be too hung up if you have to do some of these things. As long as it's not too destructive, we always make sure we come back with something good to remedy that.
Excellent. Just one last question that's come through. Like, so if you're going to use a biological inoculum, let's say a worm juice for argument's sake, and will the ammonium used at planting, will that be detrimental to the microbes that you put on there? So a little bit, probably not, but a lot, yes. Yeah, good question. Well, I did some trials this year on particularly canola. Like we find in the mixes, if any pressure is going to happen with insect damage, it's generally the brassicas, your radishes and things. They're the first thing they seem to go to. And I've sort of been looking and observing, in our paddocks, you have volunteer canola, comes up after a summer rain with no fertiliser, no seed dressing, nothing on it. And it grows the size of a dinner plate looking $1 million with no insect pressure. And the minute we buy these seeds and they've got all the sides on it and we put all this nitrogen and different things with it, we seem to get hammered with insects. So there's a bit of research and data to say out there that if we don't have the moly and different things to help the plant metabolise all that nitrogen, you can get, easy pickings for the insects or, different nitrates and things in there. So, yeah, you've got to be careful. We've sort of done, always pushing the boundaries. This year we didn't sow with any N. We put nitrogen fixing bacteria and things like that as a bactar and things in the seed with the seed, and then look at getting it on foliar so we don't have that damage effect. But, a little bit of N, it's like anything. A little bit can be very beneficial to giving it some early vigour and getting it up out of the ground, but too much all at once can sometimes create those issues. So maybe splitting some. There's a lot of research out there to say just throw it all up front up at once, but then you've got to be prepared to face some of these issues that we're facing. So maybe a bit more balanced approach, nutrition and some foliars we found to be very effective. Excellent. All right, well, we're going to have to probably pull up there. It's we've come to the end of our time. Just like to thank everybody for staying with us for the duration. And with everything that's been going on today, and there's a lot of information there, don't let it scare you off. Just go out and try something. And Grant and myself are always happy to answer any questions. Have you got anything to say, Darren?
Sure. So, Grant, thank you very much for the presentation, mate. It was very informative. The comments that are coming through already are very, very sort of positive. So thank you very much for your time. Anyone that's got any other questions, you might walk away from here and wish you had have answered. You've got my email address on the invitation, so please send them through to me. I'll filter them and send them on to both Luke and Grant, and we'll make sure we answer everything that we can if we've missed anything. So again, Luke, thanks for your time as well, and Grant, and we look forward to hosting many of these.
No worries. Well, thanks for having me, guys, and it's been a pleasure.
Righto. Thanks, Jess, as well in the background for filtering all those questions for us and sending them through.
No problem. Thanks, everyone.
Righto. All good, guys. Hope that was informative for you all.
Yep. No worries.
Thank you.
Thank you.
Bye.
See ya.